Good day. Today I would like to introduce the application integration framework for large language models, which is designed to optimize the performance of LLMs in batch processing tasks, minimizing token usage and processing time. Our framework includes three essential components: the sieve, the circuit breaker, and the optimizer. The sieve ensures output matches the required format. The circuit breaker prevents infinite loops due to repeated errors, and the optimizer will optimize batch processing to enhance efficiency. So the experiment that we are conducting is emotion analysis of a batch of sentences using OpenAI. So let's begin with the sieve module. Basically, consider an input sentence that needs emotion analysis. The sieve will read sentences and assign ID, analyze sentences using LM, and then finally it will check the results. So let's look into it. So it will generate a unique ID for each sentence using these methods and will assign ID to it after reading the sentences from a CSV file. And using analyze sentences method, the sentences are analyzed for emotions by the LLM, and the sentences and the prompt instruction both are fed into the LLM in a single prompt, and the model that we are using is GPT 3.5 Turbo. The main part in this module is to evaluate the result generated by the LLM. The check result method will check the output to ensure that they conform to the expected JSON format. And the common LM output problems including missing results or additional results are being evaluated here. It also checks if the LM generates invalid results that are not prompted. For example, emotion happy is generated instead of the correct emotion joy. Uh, and we have extra methods here to analyze incorrect results again, as this will form a loop here. So if the outputs generated by the LM is consistently incorrect and do not match the format required, it will form an infinite loop to continuously reanalyze the incorrect output. So how do we break this infinite loop? We're actually using the circuit breaker logic to control the reanalysis process of the incorrect output and break the cycle caused by sieve. So methods like increment failure and should break methods will manage failure counts and check if the failure threshold is exceeded. So this breaker method will process and reanalyze the results and stop analysis for consistently incorrect outputs. For example, if a LLM repeatedly produces incorrect outputs for a particular input, which means that the previous incorrect output is the same with the current output, we increase the unique failure count and remove it from the wrong list to avoid it to be reanalyzed in the next try. And we also can configure the retry count so that the circuit breaker will detect it and stop further analysis after a configurable number of retries. So lastly, we also have the optimizer that is designed to dynamically optimize batch processing. Um, we use this optimize method to optimize the number of inputs in a single prompt. For example, if 10 input sentences are prompted and it cannot produce correct output, then only we use the binary search optimization methods to try a smaller batch size such as 5 input sentences. If it can be produced, if it can produce correct output for 5 input sentences, then we will try a larger batch size such as 8 inputs. It continues the logic until an optimal batch size is found. By doubling the batch size when no errors are detected and reducing it according to the number of correct outputs, the optimizer ensures minimal token usage, and improve processing time. In the end, the framework will calculate and print the processing time to demonstrate its efficiency. Now let's see the framework in action through a simple demo. We'll observe how it reads sentences, analyze emotions, and handles errors, and also optimize the batch size. As you can see, the optimal batch size is 10, which is the number of inputs prompted into the LM, and the processing time is 5.37 seconds. In conclusion, the framework ensures accurate output format, prevents infinite loops due to errors, and optimizes batch processing for efficiency. So that's all from me today. Thank you.